Hi students, today we have to see simple electric circuits and planetary motions. Okay, in this section, first of all we have to see simple electric circuits. Okay, already we know that what is a simple electric circuits, how to find the simple electric circuits, etc. Already we know that. Okay, here in this section we consider linear differential equation. Okay, in this section we have to consider what is this linear differential equation. L into di by dt plus Ri equal to E. Okay, this is a linear differential equation. This one is also already we know that this equation. Okay, we are the science students. Okay, this is a linear differential equation. Already we know that what is the value of L, R, I, E, etc. Okay, I had to recall that the circuit consists of a source of electromotive force. Capital E is what is this? A source of electromotive force. It is already we know that it is denoted as what is this? EMF. Okay, which derives what is the electromotive force? Which derives electric charge and produces a current, capital I. Okay, what about R? It is a resistance. Okay, it is not a simple R, it is an ER. Okay, a resistant R which opposes the current by producing a drop in EMF of magnitude. ER is equal to what is this? Ri. Okay, this equation is also already we will know that it is an Ohm's law. Okay, whereas physics students already we will know that this one ER is equal to what is this? Ri, Ohm's law. Okay, and the next is L. Okay, what about the L? The inductor of inductance, capital L, which opposes any changes in the current by producing a drop of EMF of magnitude. EL is equal to what is this? L into dL divided by dt. Okay, this is also already we well known that all these. Okay, just I had to recall that it is a simple electric circuits. We are using that equation, simple electric circuits, L into di by dt plus R I equal to E. This is a what is this? First order linear differential equations. Okay, already I had to explain it. And the next we want to move on problems. Okay, the first problem is solve L into di by dt plus Ri equal to E naught. E is given here. This is an E naught linear differential equation with the following initial condition. I naught is the current flow initially, and E naught is the constant EMF impressed on the circuit at t equal to 0. Okay, it is given. We had to solve. Okay, we had to solve this equation. What is this? The linear differential equation. Okay, solution. I tried the given equation L into di by dt plus Ri equal to E naught, which implies we have to solve this one. It is a differential equation. Already we note this. We notice that already we well known that this is what is this application of differential equation. Okay, just we have to solve it. How to solve the differential equation? We have to separate the variables. We are using variable separable method here. Okay, on the purpose we have to simplify this one. L into di by dt is equal to E naught minus Ri. Okay, Ri divided by, are using variable separable method, Ri divided by E naught minus Ri is equal to dt divided by L. Okay, Ri by E naught minus Ri here divided by I also there. Then we are using log formula. Just we have to integrate, we get minus 1 by R. Okay, in I in front of I is what is this? Minus R there. Then I using what is this? Minus 1 by R into log of E naught minus Ri equal to 1 by L into T. Okay, 1 by L is in constant. Dt integration is we get it is what is this? T plus C. Therefore, we get it is what is this? Log of. Okay, just you have to multiply 1 by R on that side. Tried here. I had to simplify this one. We get it is what is this? Log of E naught minus Ri is equal to minus R by L into T plus C. Okay, c is a constant. You have to write simply write it as c. Okay, initially, what is it is given initially when t equal to 0. Okay, here I is also given in our problem. You have to see that with the following initial conditions. I naught is the current flow initially. E naught is the constant EMF impressed on the circuit at t equal to 0. Okay, we have to consider only the initial conditions. Okay, and then we have to solve it. Okay, on the purpose we have to write initially when t equal to 0, I equal to what is this? I naught. Hence, at substitute t is equal to 0 in the last equation, we get it is what is this? I equal to I naught also, at to substitute, we get it is what is this? Log of E naught minus R I naught is equal to C. Okay, we had to find what is this C. The constant, you had to substitute that C in the above equation. Log of E naught minus Ri is equal to minus R by L into T plus log of E naught minus R I naught. Okay, I had to simplify this one. We had to kept it into what is this? So logarithmic terms on one side and the remaining constants on another side. Okay, log of E naught minus Ri minus log of E naught minus R I naught is equal to minus R by L into T. Okay, already we know the logarithmic rules. Log A minus log B is log of A by B. And using that rule here also, log of E naught minus Ri divided by E naught minus Ri naught equal to minus R by L into T. Okay, then I have to taking exponential on both sides. Okay, I have to cancelling the logarithmic terms, and then we have to find the value of phi. Okay, what is our aim? We have to find the value of what is this I. Just we have to solve the linear differential equation in our question. Okay, and then we have to find the value of what is this I. On that purpose, we have to taking exponential on both sides. Therefore, E and the log are cancelling. We get it is what is this E naught minus Ri divided by E naught minus Ri naught equal to e power minus R by L into T. Okay, then I write just to multiply E naught minus Ri naught on that side. We get it is what is this E naught minus Ri equal to E naught minus Ri naught into e power minus R by L into T. Okay, it is also just a simplification. Okay, and then I write minus Ri. I have to keep it this E naught here, the plus E naught goes to what is this minus E naught plus E naught minus Ri naught into e power minus RT by L. Okay, already I told that we have to find the value of what is this I. Okay, then I is equal to, just we have to multiply divided by what is this minus R on that side. Okay, I is equal to what is this E naught by R is equal to E naught by R plus E naught minus Ri naught divided by minus R e power minus RT by L. Therefore, I is equal to E naught by R plus I naught minus E naught by R. Okay, just we have to divide minus also. Okay, I have to multiply, I have to simplify the minus also, e power minus RT by L. Okay, just enough. This is the solving value of linear differential equation. Which is enough. It is a simple unit. Already I told you that simple electric circuits as well as it is a simple unit. Okay, we get an answer. Okay, and notice the current I. Okay, I is already we know that. Okay, we are the science students. Already we know that I is and what is this current consists of a steady part of. Okay, this one is what is a steady part of what is this E naught by R. And transient part of I naught minus E naught by R into e power minus RT by L. Okay, this is also already we know that how to find the steady part and transient part. Okay, we know that the transient part tends to 0. Okay, the transient part tends to 0 as t tends to infinity. Okay, if it is the last equation, the above equation, we have to find the value of phi, and that equation we have to substitute t tends to infinity. As well as it is, what is the meaning of this one? E naught by R plus I, E naught by R is then what is this? Steady part. The second one is what is this? Transient part. In the transient part, the part tends to 0. What is the meaning of that? It tends to 0. When it is tends to 0, the time tends to infinite. Okay, the t tends to infinity. We have to substitute. We get the second part, transient part. E power minus infinity, automatically it is go to what is this 0. And and consequently we get it is what is the second part transient point 0, automatically we get what is this I is equal to what is this E naught by R. I automatically we get it is what is this E naught by R. E naught is equal to we get it is what is this Ri. Okay, this shows that Ohm's law is nearly true for large T. Okay, here this shows that, okay, we had substitute transient part equal to 0. Okay, the time have more time or taken that circuit means we get automatically the transient part goes to 0. We get I is equal to E naught by R. The I is equal to E naught by R is what is this? It is an Ohm's law. Okay, okay, one is related to another. Okay, already we well known that these values, okay, Ohm's law, etc. Okay, Ohm's law is an one-word question. Okay, and the next we want to move on planetary motions. Okay, we want to move on. What is this? Planetary motions. In the planetary motions, how to derive the planetary motion, etc. Already we know that Newton's law of gravitational attractions. Okay, we know that Newton's law, Kepler's law, Kepler's first law, second law, third law, as well as we know that the Newton's law, Newton's first law, second law, third law, Newton's Newton's law of gravitational attractive states that two particles of masses m and m dash at a distance r apart attract one another with equal and opposite forces of magnitude g m dash by r squared, where g is a gravitational constant and etc. Already we know that all the values, okay, it is in Newton's law. Okay, the planetary motions of planetary motion states that Kepler's law. How to find the Kepler's law? We are using the Newton's law. We get in Kepler's law. Already we well known that all the items. Okay, first we have to see in Newton's Kepler's first law. Okay, Kepler's first law is the orbit of each planet is an ellipse with the sun at one focus. Okay, it is a Kepler's law. And the Kepler's second law, the radius vector r from the sun to a planet sweeps out equal areas in equal intervals of time. Okay, it is a second law. And then Kepler's third law is the square of the periodic time of a planet is proportional to the cube of the semi-major axis of its orbit. Okay, how to find this Kepler's law? Already we well known that we are using that Kepler's law 1, 2, 3 here. Okay, planetary orbit. Eccentricity, already we know that. Here we are using the eccentricity formulas and the kinetic energy, potential energy. Okay, we are using that. We have to find the planetary orbit also. Okay, we have to find the planetary orbit also. Okay, next we want to move on the problem. That problem is prove that for a planetary orbit the eccentricity E equal to root of 1 plus E into 2h squared divided by mk squared, where is the total energy? Where is the, what is this total energy? Okay, our solution is, already we know that V equal to velocity is equal to dr by dt into I1 plus r into d theta by dt j1. Okay, hence we have to taking square. Why I have to find these values? We have to find the planetary orbit. Okay, here it is on planetary orbit means we had a planetary orbit of the eccentricity. Okay, we had to find what is this? Capital E is equal to what is this? Capital E value we have to find. Okay, capital E value we had to find, and also we had to prove that E is equal to root of 1 plus E 2h squared divided by mk squared. Okay, and that purpose total energy, where it is, then what is this total energy? How to find the total energy? Kinetic energy, potential energy we have to find. Another we have to substitute capital E is equal to T plus V, we get an answer. Okay, we know that V is equal to dr by dt I1 plus r into d theta by dt j1. Here V squared is equal to dr by dt the whole square plus r squared into d theta by dt the whole square. Just we add squaring. We get an answer. Okay, I square j squared, so what is this complex, and we have to squaring on that one, we automatically we get it is 1. Okay, kinetic energetic formula already we know that T is equal to 1 by 2 into mv square. Okay, 1 by 2 into mv square we have to find. What is this? Dr square by dt, dr by dt the whole square plus r square into d theta by dt the whole square. The potential energy is given by V equal to integration Km by r squared into dr. Okay, already we know that it is what is this? Newton's law of gravitational force. Okay, directional towards the magnitude values. What is this? Km by what is this? R square. We have to substitute that value here. Okay, integration Km by r squared into dr. Okay, and just we have to integrate with respect to r. 1 by r squared integration is, we get it is what is this? Minus 1 by r. Km or constant, we get it as V is equal to minus Km by r. The constant of integration is chosen to make V vanish to infinity. Okay, if it is at a substitute plus c means it is vanish to infinity, and the purpose the constant is negligible. Okay, we have to substitute E is equal to what is this? T plus V. T already we have to find, V also already we have to find. Just we have to substitute these two values in E is equal to T plus V. Okay, 1 by 2 into m into dr by dt the whole square plus r square into d theta by dt the whole square minus km by r. This is equation number 1. I had to keep it that equation. Okay, initially when theta is equal to 0. Okay, we want to move on our problem. We have to find the value of E. What's our aim? We have to find the eccentricity. Okay, when t is equal to 0, I have to substitute. Okay, already we know that h squared by k by r equal to 1 plus e cos theta. Eccentricity formula. Okay, eccentricity value already we know that. Okay, I have to substitute that one. We get theta is equal to 0. I have to substitute automatically. We get cos 0 value is 1. Then we get what is this? R is equal to h squared by k into 1 plus e. And dr by dt is equal to 0. Also, d theta by dt is, what is this? It is h squared by r squared. Okay, just to add to simplify, differentiate with respect to t. We get automatically, there is no t in our formula, then automatically it is 0. If it is to find the value of d theta by dt, okay, d theta by dt, we get it is what is this? H by r square. Okay, substitute all the values in equation number 1. E equal to 1 by 2 into m. Dr by dt value is equal to 0 plus d theta by dt is h by r square. Then we get it is what is this? H squared by r power 4. Already into r squared is r there. R squared is cancelling. The remaining is 1 by r squared minus km by r. Okay, E equal to 1 by 2 m into h squared by r squared minus km by r. Hence, E equal to 1 by 2 m into what is this? H squared by r squared value. Already I had write that one, r squared. Here in this value, r squared is, what is this? H squared by k squared into 1 plus e squared. Okay, just to add right, and then add some like here also 1 by, k m by r value. Okay, already we know that r value. I had to find that r value, h squared by k into 1 plus e. I had to substitute that value here. K squared m into 1 plus e divided by h squared. On h squared is cancelling. The remaining is divided by h squared. I have to simplify this one by 2 m. Okay, I have to simplify this 1 by 2 m into k square 1 plus e the whole square divided by h square minus k square m into 1 plus e by h square. Okay, we have to taking common outside by what is this? K square m is common divided by 2. H squared is also common. I have to taking common outside 2 also. I have to taking common outside. I have to simplify this one. We get an answer. Okay, k k squared m by 2h squared. The remaining of the first term is 1 plus e the whole square minus we are to taking k squared m by h squared divided by 2 also we are to taking common square, and then we have to multiply 2 into 1 plus e. Okay, then we get it is what is this 1 plus e the whole square. We have to expand this 1 plus e square plus 2e minus 2 are just inside we have to multiply this 1 minus 2e plus 2e is cancelling. We get it is what is this minus 2 plus 1 is cancelling. We get it is what is this e square minus 1. Okay, what is our aim? Eccentricity we had to calculate. Small e we had to calculate. And this purpose we had to simplify this one. E square minus 1 is equal to reciprocal e into 2h square divided by mk square. Therefore, e equal to what is this? Just we have to, that minus 1 goes to, we get it is what is this plus 1 plus e 2h square divided by mk square. Okay, what about this is an e square, then e automatically equal to what is this root of 1 plus e 2h square divided by mk square. It's also very very important. We have what is this eccentricity value. Okay, and the next problem, so that the speed v of a planet at any point of its orbit is given by v squared equal to k into 2 by r minus 1 by a. Okay, we have to prove that this one, it is also very very important. V squared is equal to k into 2 by r minus 1 by a. We have to prove that by the principle of conservation of energy. Okay, this is a planetary motion. We are using all the energies. Okay, if it is we have to find the value of E means we are using all the energy, kinetic energy, potential energy. Okay, we are using all the energies. Okay, by the principle of conservation of energy. Already we know that all the energies. Okay, just right here it is what is this 1 by 2 into mv square minus km by r equal to E. Okay, this is also already we have defined that value. Yes, we have defined that the last one 1 by 2 m into h square by r square minus km by r. Okay, just we are using this value. Suppose we are using this value now, I had write that last problem also. Okay, 1 by 2 into mv square minus km by r is equal to capital E. Capital E already we have defined that one. The last one mk square by h squared into e squared minus 1. I had to substitute that value here. 1 by 2 into mv squared is equal to mk squared by 2 h squared into e squared minus 1 plus km by r. Okay, I had to taking common outside by what is this? How many values are there? K squared. V squared value I had to find. V squared is equal to k squared by h squared into e squared minus 1. M is cancelling. M is cancelling, and the 1 by 2 is also cancelling. But the second term there is no 1 by 2, just try to multiply the 2. Okay, then automatically we get it is v squared is equal to k squared by h squared into e squared minus 1. M is cancelling, m by 2 is cancelling. Okay, here also m by 2 is cancelling, there is no 2, just you have to multiply this one 2k by r. Okay, here we have to write what is this? K is common, after taking common outside 2 by r. First second term we have to write plus k by h squared into e squared minus 1. Okay, k by h squared into e squared by minus 1. Okay, I have to check our problem. There is no e, h, k, etc. Okay, what is this? I have to see our problem. V squared is equal to what is this? K into 2 by r minus 1 by a. Okay, on that purpose we are using, already we know that since h squared by k is equal to L, equal to what is this? B squared by a. And b squared is equal to what is this? A squared into 1 minus e squared. Okay, I have to substitute this value here. Therefore, 1 minus e squared, automatically we get it is what is this? B squared by a squared. E squared minus 1 squared are there. Then I'll write, just to write the minus, we get it is what is this? Minus b squared by a squared. Here also, k by h squared. H squared value is what is this? H squared by k. K by h squared in our problem. But we have what is this? H squared by k. H squared by k is what is this? B squared by, then I write the reciprocal a by b squared. When a is cancelling, b squared is also cancelling. We get it is automatically it is what is this? V squared is equal to k into 2 by r minus 1 by a. Okay, which is enough. What is this? Planetary motion. Already I told you that it is a simple unit in our syllabus. Okay, it is enough. We have to do more problems in our exercise. We have to see to simplify that one. Okay, thank you.